In this section, we are constructing confidence intervals for population proportions. So we are not working with means, we are working with probabilities. So P is the population proportion of successes. P hat is the sample proportion of successes, and this is the point estimate for P. Q hat is the sample proportion of failures, and Q hat is equal to 1 minus P hat. And this is because all of the probabilities for a given scenario have to add up to be 1. N is the sample size, and X is the number of successes in the sample. So P hat is equal to X over N. P and Q are associated with the binomial distribution, but the binomial distribution can be approximated by the normal distribution when n times P hat is greater than or equal to 5, and n times Q hat is greater than or equal to 5. The definitions for the level of confidence and the critical values are the same as they were when we were working with the z-intervals. The margin of error is equal to zc times the square root of P hat times Q hat divided by n. And this formula can be used when n times P hat and n times Q hat are both greater than or equal to 5. And to construct the confidence interval for the population proportion, P is between P hat minus E and P hat plus E. In a survey of 1,000 people, 372 said that they were happy with their current computer model. Construct a 95% confidence interval for the population proportion of people who are happy with their current computer model. Interpret the results and show all work. So let's write down our information first. We know that n is equal to 1,000 and x is equal to 372. P hat is equal to x divided by n, so 372 divided by 1,000, which is equal to 0.372. Q hat is equal to 1 minus P hat, so 1 minus 0.372 is 0.628. Now, before we can construct the confidence interval, we need to check that n times P hat and n times Q hat are both greater than or equal to 5. So n times P hat is 372, and n times Q hat is 628. And those are both greater than or equal to 5. So we can construct our confidence interval. Our critical value, Z95, is 1.96, and that comes from the table. So now we can calculate our margin of error. That's 1.96 times the square root of 0.372 times 0.628 divided by 1,000, and that's 0.030. Now we can construct our confidence interval. So P is between 0.372 minus 0.030 and 0.372 plus 0.030. So P is between 0.342 and 0.402. Now for the conclusion, I'm going to convert both of these to percentages. So I want to move my decimal place 2 places to the right. So with 95% confidence, we can say that the true population proportion of people who are happy with their current computer model is between 34.2% and 40.2%.